Welcome to Java with Hawa. So today we'll be solving this practice it problem called remove min. This is within the stacks and queues chapter. So let's get started. So our problem is write a method remove min that accepts a stack of integers as a parameter and removes and returns the smallest value from the stack. For example, if a variable s stores these values and we make the following call, the method removes and returns -8. So n will store -8 after the call and s will store the following values. If the minimum value appears more than once, all occurrences of it should be removed. For example, given the stack above, if we again call remove min, it would return 2 and leave the stack as follows. You may use one queue as storage and no other structures to solve this problem. Alright, so I already laid out my thought process for this problem, and I'm going to go ahead and switch to my whiteboard here. So here's our original stack. It has 2, 8, 3, 19, 7, 3, 2, 3, 2, 7, 12, -8, and 4. So here are the steps that I am aiming to take. Right. So the first step I'm going to do is to empty all the contents of the stack into my queue, so that way it's easier for me to compare and manipulate. So if I were to empty all the contents of this stack into the queue, let queue represent my queue. My queue would look like, since stack is last in first out, the 4 would come out first and then -8. So my queue would look like this: 4, -8, 12, 7, 2, 3, 2, 3, 7, 19, 3, 8, and 2. So this is my queue right now after performing the first step. After that, we're going to initialize some variable num to the first element of the queue, which would be 4. Then we're going to remove that element from the queue and add that element back into our stack. So to help you get a visual of this, what I have in mind is to have some variable num equal to queue.remove, so the first element in the queue. And then what we're going to do, I basically removed and set it to num in one step. After that, what we're going to do is add this back into our stack. So right now our stack is empty, so all we'd say is s.push num, and that should add it back into the stack. So the reason I'm doing this is so I am able to compare each number with this num and see whether the number is smaller than or bigger than it, or equal to. Alright, so step 3, after that we move on to step 3, and let me move this here. We move on to step 3, and it says compare each peak value of the queue to the num value. So we can update num if a smaller number is found, and then remove those peak values and add them into the stack simultaneously. So this is a bit confusing, but all I'm saying is we have our stack. The only number it contains is 4, right? Right now our queue, since we removed 4 from it, our queue has -8, 12, 7, 2, 3, 2, 3, 7, 19, 3, 8, and 2. What I'm saying is compare this number with this num. Let me write down here. Num equals 4. So we compare this number with num. If it's less than num, then we update num to become -8, but we still add all of these numbers into our stack. So if this were to execute correctly, by the end of step 3, our queue would be empty and our stack would contain 4, -8, 12, 7, 2, 3, 2, 3, 7, 19, 3, 8, and 2. And our queue would be empty. And then our num would be -8. Assuming step 3 works correctly, this is what our num would return. And then step 4, to remove the minimum number and its duplicates, because remember the method wanted us to remove the minimum number and any duplicates of it. All we have to do is step 4, compare each number of our stack to this num value -8. So we'll iterate or use a while loop to go through this stack and compare each number to -8. If the number equals -8, all we have to do is completely remove that number and disregard it from the stack. And as we remove these numbers, we're going to be storing them back into our queue. So our queue would look like 2, 8, 3, 19, 7, 3, 2, 7, 12, -8, well, actually, -8 would be removed. So now we're assuming that step 4 worked correctly. So it would have removed -8, and this is what we would be left with. And step 5, we want to restore our stack how it was in the beginning. So, well, not how it was in the beginning, how it is now without the minimum value in there. So all we have to do is take the contents of this queue and pour them into a stack. So essentially, we'd use a while loop and say while queue is not empty, all we'd say is add all of these contents back into our stack, and we have our answer right there. After step 6, when we return num, that will give us our solution. Our stack will be restored, and we'll have the minimum value. So this would be s.push q.remove, and that should be the solution for this question. Now I'm going to move over to my Eclipse and start coding. Alright, here we go. Oops. I'm gonna be using this here. Alright, here we go. So I have these numbers already set up in my stack. Now we're gonna write the method down here. So we have a public static integer num, and it's gonna take a stack of sorry, it's not called num. We're returning an integer value, and then it's called remove min. It's going to take a stack of integers as a parameter, so we'll call that s. And here we go. Oops, this should be capitalized. Alright, so the first step that we did was empty all contents of the stack into it. Well, first we're going to set up our storage. So we're going to have q integer, we'll call it q, equals new linked list of type integer. And then now we're going to empty all contents of our stack into our queue. So we're going to say q.add stack.pop. So this will run as long as the stack, until the stack is empty, and it'll give us all the values we're looking for. So after that, we added our value. We removed the first value from the queue and added it to our stack and stored that value as num. So what I'm going to do here is say int num equals q.remove, and then we're gonna add that back into our stack, since now our stack is empty. So we just say s.push num. Alright, cool. And then after that, we are going to be essentially, like we said here, comparing this num with the numbers in the queue. So here's what we have to do. We're gonna say while our queue is not empty. If we're gonna write an if statement and say if q.peak. So right now we're gonna have 3 test cases: one for less than, one for greater than, or equal to. So we're gonna say if q.peak is less than num, then all we want to do here is say we're gonna update the value of num to that q.peak. So num equals q.peak, and then we're going to remove that value from the queue so we can start testing the other values, and then we're gonna add that value into our stack. Right? Sorry, we're just gonna go ahead and add it all together here. s.push q.remove. That way we're doing it at the same time, saving some time. And then we're gonna say else, meaning else if q is greater than or equal to. Then all we want to do is add those values back into our stack. We do not want to update the value of num because we're looking for the minimum number in the stack or queue at this point in time. So all we're gonna do else s.push q.remove. Alright, awesome. So now if we go back here to the whiteboard, our stack should look like this. Our num should be -8. So what I'm going to do is make the return type void for now. That way I can test some things. So right now, where does the while loop end? Alright. Right now we're going to see the value of our stack and the value of our queue. So if we had done this correctly, our queue should be empty, our stack should contain these values, and our num should equal -8. So what I'm going to do is first print out num. It's num. I'm going to print out our queue. and then I'm going to print out our stack. Call it S plus S. And then I'm just going to uncomment this out here and see what happens. So we have our original stack here. Num is -8. Our Q is empty. And our stack contains 4, -8, 12. Well, this is the top. But anyways, 4, -8, 12, 7, 2, 3, 2, 3, 7, 19, 3, 8, 2. So now that we know this step has worked correctly, we can go ahead and move on to step 4 by just dumping all the contents of our stack back into our queue. So what we're going to say is, dumping all the contents of the stack back into the queue, but also checking if our num is in there, or if there's a duplicate of it. So if that is in there, then remove those numbers. So now that we have, this is our stack, we're going to go through our stack and say, while our stack still has elements, what we're going to do is say if stack.peak is equal to num, then what we're going to say is stack.pop. Just completely disregard it and get rid of it. Else, if it's not equal to num, then all we have to do is remove that value from the stack and place it into our queue. So we're going to say queue.add stack.pop. Right, that's all we have to do. And that should remove our minimum value and any duplicates of our minimum value. So what I'm going to do here is print out the queue, because remember we just dumped all the contents into the queue besides the minimum value. And let's see what our queue is looking like right now. So right now our queue is 2, 8, 3, 19, 7, 3, 2, 3, 2, 7, 12, 4. So our -8 value is nowhere to be found, meaning this step worked correctly as it should have. And there are no duplicates of -8. Well, there was no duplicates to begin with, but if there had been, it would have removed it. And we can also test that case and say, and add another -8 and see what happens. So here we go. So here you can see there's 2 -8s, and at the end here there are no -8s, and that's exactly what we want. So now for the final step, all we want to do is restore the stack how it was originally without the minimum value. So what we have to do is say, while the queue still has elements, empty all those elements into the stack. So s.push q.remove, right? So that should give us everything we're looking for. And at the end of our method, all we have to do is return that num. And remember, we have to go back and update this here as int, and it should give us what we're looking for. Great. Alright, so I'm going to remove these from here, and then we're going to paste them into the practiceIt to see if it worked as it should have worked. Although it's not returning num here. Oh, that's because we have to sys out. So we're going to sys out move min, and it should give us our num value of -8. Oops, forgot the semicolon. Alright, so we'll get -8 here, and here's our original stack. And if we wanted to see if it restored the stack properly, all we'd have to do here is sys out the stack, and here we go. We get our original stack without the minimum values in there. So we're going to go ahead and paste this in the practiceIt. I'm going to remove the printlns that I used to test and see what we get. Alright. That's good. Alright, so all the test cases worked. It passed 13 out of 13 tests. So that is the solution for the remove min problem. I hope you guys enjoyed this video, and I'll see you guys in the next video. If you have any comments, suggestions, or recommendations, please leave them in the comments below. Alright.